Back to my YouTube channel. So in the previous session, we have detailedly understood what is the AM wave and what is baseband signal, what is AM wave, how the AM wave is generated, and how the AM wave looks like after mixing carrier signal and the information signal or the message signal. So in this session, we will try to understand the AM wave frequency spectrum. Okay, how the frequency spectrum of an AM wave looks like. Okay, so and we will try to analyze the spectrum also. So before that, so what is the frequency spectrum? What is frequency spectrum? Why it is important? Okay, so why it is needed for us to understand? We'll try to cover, and then we will slowly, if that is clear, then we can definitely move on to the next AM wave frequency spectrum. So initially, what is this frequency spectrum? So frequency spectrum is nothing but a description or the pictorial representation or the representation of various frequencies that a signal can contain. Okay, I will repeat it. So frequency spectrum is nothing but a representation of various frequencies that a signal can contain. Which signal? The signal for which we want to analyze or we want to understand in detail. Okay, so that signals how many free or what range of frequencies are there in that particular signal, that is called as frequency spectrum. So in case of AM wave, we will try to now define what is AM wave frequency spectrum. So AM wave frequency spectrum is a spectrum. Okay, AM wave frequency spectrum is a frequency spectrum in which the various frequencies are represented that an AM wave can contain. That means I'll try to tell you in different way. So AM wave is a final wave after modulation of message signal. Okay, so AM wave, whatever is there, so in that what all range of frequencies can be present, that can be represented in terms of this diagram, okay, which I am highlighting now. So that is nothing but the AM wave frequency spectrum. Means an AM wave definitely contains different frequency bands, so various frequencies. So what all the frequencies are present in AM wave are represented in this way. Okay, are represented in this way. So this is nothing but the AM wave frequency spectrum. Okay, so now frequency spectrum of AM wave is this one. So now we will try to uh, understand this frequency spectrum in a more detailed way. Okay, so now I hope AM wave frequency spectrum, what does it mean? It is clearly understood. Okay, I'll repeat once again for you. AM wave, what in AM wave, whatever frequencies are present, that is represented in terms of this particular diagram. So now next question arises, why this frequency spectrum is really important for us to understand? Because this is simple way I can tell you, this is used for signal analysis. Because in signal which we want to study in detail, what all the frequency ranges are present, in order to understand that we have to plot frequency spectrum in this way and we have to study it. Okay, so this is the frequency spectrum of AM wave, which you can see it now. So this is the origin. Okay, this whatever I am highlighting, this is nothing but the amplitude axis or the y-axis, and this is nothing but the x-axis, which is frequency. So that means frequency spectrum is a representation of, or the graphical representation of, amplitude in y-axis with respect to frequency in x-axis. Okay, so x-axis consists, as you can see here, it consists of frequencies, and y-axis consists of amplitude. Amplitude, how it is measured? Frequency unit is hertz, Okay, it is a standard unit. So amplitude is usually measured in volts. How many volts? Usually it in terms of millivolts or volts. So in this way. So now we will try to analyze. So okay, so this is the y-axis amplitude, x-axis frequency. So as you can see, there are two side bands. There are two side bands in this uh, representation. So what are the two sidebands? We will try to understand. There are two types of sidebands which are available. The first one is upper sideband and the next one is lower sideband. So upper means the next, the upper one. Okay, the which upper one I will try to tell you. So frequency band from FC to FC plus FM means FC. This is the FC means what is FC? So FC means carrier frequency. FM means modulating signal frequency. So this is okay, FC to FC plus FM. This is FC plus FM. Okay. So this is FC plus FM. So that means FC to FC plus FM, this particular area is called as upper sideband. Okay. And FC minus FM to FC is called as a lower sideband. So this is called as lower sideband. So this is called as upper sideband and this is called as lower sideband. Okay. So in the similar way, here also, left side also, you can see here here also it is the same way. So lower sideband and upper sideband, similar way. So now the question arises. So now it is clear. First point is clear. Frequency band from FC to FC plus FM, upper sideband, and FC minus FM to FC, it is lower sideband. So now I think this is clear, and this is repeated in the this uh, part also. Okay. So now the question arises how this bandwidth to 2FM comes. So if you add now, see FC both sides if you add or in simple way if you add then you will get 2FM as the answer. You can check once. Okay. So minus FC cancels with plus FC, minus FM plus FM, and in this way totally at last you will get as 2FM. So bandwidth, as we can mention, we can analyze and say from this AM wave frequency spectrum as bandwidth is equal to 2FM, two times of modulating frequency is the bandwidth. So what is this bandwidth? The range of frequencies which it can maximum cover is 2FM, two times of modulating frequency. Suppose say now we will try to analyze this formula. Suppose say modulating signal frequency is 2 hertz. Okay, and bandwidth at that time I can calculate as 2 into 2 which is 4 hertz. If FM is 4 then 4 to 8 this is 8 hertz. So this in this way we have to understand. So now this is very important for you to understand and you it will be helpful definitely for you to solve any of the competitive examination. And from this figure, one more important conclusion you can try to understand or draw the conclusion. So the maximum amplitude of carrier is how much? From this figure, you can see and tell me. Maybe it is very clear that the maximum amplitude of carrier frequency is AC by 2. What is this AC? Amplitude of carrier signal. So if amplitude of carrier signal is 2 volts, then definitely it will be 1 finally. Maximum for amplitude of carrier frequency is nothing but carrier signal is nothing but this one AC by 2. AC by 2. So you can substitute the value of AC amplitude of carrier signal and you can definitely get the maximum amplitude that FC can take. Okay. So similarly you can try to calculate FC minus FM, FC plus FM, lower sideband, upper sideband. How much maximum amplitude it can take is mu AC by 4. Mu AC by 4 is the maximum amplitude which FC which sidebands can take. So what are these sidebands? As I already told you. So sidebands can take, from this we can conclude that the maximum amplitude that frequency that carrier signal can take is AC by 2 and the maximum amplitude which sidebands can take is mu AC by 4. Okay. So now we are interested in calculating what is this mu. In the last discussion which I have told you, I told that mu is nothing but the modulation index, and I have also told that in the next session we'll be covering the modulation index. So now we will try to understand this modulation index. So modulation index, so modulation index is nothing but mu equals to, it is represented by mu. So why this modulation index is really important? Definitely, see, if you want to calculate maximum amplitude which the sidebands can take, mu AC by 4 I told, so we have to know this mu. Okay, so because of this we are calculating mu. I hope it is clear now. So the formula for calculating mu is a max minus a minimum by a max plus a minimum, means whatever maximum amplitude is there and what is minimum amplitude, a minimum is there, we have to use it and substitute here. So what are the maximum amplitude, what are the minimum amplitude, it will be clearly given in while solving the problems. So you can definitely, if not, a diagram will be given of a signal through which you can definitely analyze like what is the maximum amplitude and minimum amplitude a signal can take in with respect to that particular diagram. So based on that, you can substitute in this equation for mu, and you can get the value of mu modulation index. So Amax, how to calculate? There is again a, this one. So with Amax is nothing but AC into 1 plus mu, and A minimum is nothing but AC into 1 minus u. So this C with, because of this equation has, we can derive this equation. Final, this equation mu equation has arisen only because of this. A max is nothing but this one, and A minimum is nothing but this one. Once if you combine these two equations, then you will get this equations. Otherwise, if we try to segregate this equation, we'll get individual equations. What is the value of A max and what is the value of A minimum? So A max, as I told you, it is a maximum amplitude, and A minimum is nothing but the minimum amplitude. I hope these things are very clear now. What is frequency spectrum in general, and with respect to AM wave, we have already defined what is this. We have analyzed also what is frequency spectrum. If there is any still doubt, so you can please comment in the YouTube comment section. And if you are not yet subscribed, please subscribe to my YouTube channel and press the bell icon to get the latest updates. Okay, so not only EM wave, you can comment regarding any of the topic which is related to physics in general and electronics and communication, or electrical and electronics in particular. Whichever the topic you want me to conduct, you can please comment in the YouTube comment section. I will definitely try to cover that particular topic as soon as possible. So once again, yeah, thank you. Have a nice day. Bye.